Hello children, welcome to the term 3 science video session. In this science video session, you are going to learn the lesson Magnetism from physics of standard 6. Come, let's get started with the lesson. Unit 1 Magnetism. Introduction. Children, you might have seen magnets. Have you ever enjoyed playing with them? Yes. So, what is magnet? A magnet is a material that can pull certain types of metal towards itself. Unlike many other forces, magnetism doesn't have to touch the object it affects. Magnetism is a fascinating invisible force. It influences the environment around it. So, in this lesson, we are going to learn the discovery of magnets, magnetic and non-magnetic materials, magnetic poles, properties of magnets, and the principle of Maglev train. Come, let's enter into the lesson. Discovery of magnets. About 2500 years back in a place named Magnesia in Greek, Magnus was rearing his goats. After some time, he took a nap. When he woke up, he surprised. His iron capped stick stuck on the rock and stood erect. His iron nailed boots also stuck on the rock. The entire village assembled there and wondered. Each and every one expressed their views. What might be the reason for the stick to get stuck on the rock? Yes, you're right. That is a magnetic rock. People found it attracting not only for the stick of Magnus, but also for all the materials made of iron. The more rocks of these kinds were found worldwide, these magnetic rocks were named magnets, and the ore is called as magnetite, after the name of the boy, Magnus. The name is also supposed to come after the name of the place, Magnesia, in which it was found. Magnetite was the ore with attracting property found in that region. Magnetites are natural magnets. They are called magnetic stones. Natural magnets do not have a definite shape since they are used for finding direction. They are also called leading stones or lodestones. Magnet of different shapes. After learning the method of changing the piece of iron into magnet, that is magnetization, we have been making and using several kinds of magnets. Such man-made magnets are called artificial magnets. Bar magnet, horseshoe magnet, ring magnet, and needle magnet are generally used artificial magnets. Oval shape, dish shape, cylindrical shape magnets are also available. Magnetic and non-magnetic materials. Substances which are attracted by magnet are called magnetic substances. Iron, copper, nickel are magnetic substances. Substances which are not attracted by magnet are called non-magnetic substances. Paper, plastic, rubber, wood are called non-magnetic substances. Magnetic poles. To find out the magnetic poles of a magnet, we need to do a simple activity. Place some iron filings on a paper. What is meant by iron filings is nothing but small pieces of iron. Place a bar magnet horizontally in the filings and turn it over a few times. Now lift the magnet. What do you see? Which part of the magnet has more iron filings sticking to it? Yes, at the edges. The parts of the magnet those attract the largest amount of iron filings are called as its poles. The attractive force of the magnet is very large near the two ends. These two ends are called its poles. Finding directions with a magnet. To find out the direction with a magnet, tie a piece of thread to the center of a bar magnet and suspend it. Note in which direction the magnet starts. Draw a line on a sheet of cardboard or the table along the direction in which the bar magnet starts. That is, a line parallel to the bar magnet. Turn the magnet gently and let it come to stop again. Repeat it 3 or 4 times. Does the bar magnet stop in the same direction each time? In which direction does the magnet stop every time? This is roughly the north-south direction, isn't it? The end of the magnet that points to the north is called the North Pole. The end that points to the south is called the South Pole. A freely suspended magnet always comes to rest in north-south direction. Do you know the directive property of magnets has been used for centuries to find out directions? Around 800 years ago, the Chinese discovered that a suspended lodestone stops in the direction north-south. Chinese used these lodestones to find directions. The navigators of that country used to keep a piece of lodestone suspended in their boats, and during a storm or mist, they used the lodestone to locate directions. Magnetic compass. A compass is an instrument which is used to find directions. It is mostly used in ships and airplanes. As a rule, mountaineers also carry a compass with them so that they do not lose their way in unknown places. The compass has a magnetic needle that can rotate easily. The marked end of the needle is the north pole of the magnet. Properties of magnets. When two magnets are brought close to each other, they are either pulled towards each other or pushed away from each other. When the magnets are pulled towards each other, they are said to attract each other. When they are pulled away from each other, they are said to repel each other. So, here in the given diagram, the unlike poles, south north, north south, attract each other. Then the like poles, north north and south south, repel each other. So here the unlike poles attract each other, like poles repel each other. Do magnets lose their properties, and when? Magnets lose their properties if they are heated or dropped from height or hit with a hammer. And magnets lose their properties when they are placed near cell phones, computer, DVDs. These objects will also get affected by magnetic field. Storage of magnets. Improper storage can also cause magnets to lose their properties. To keep them safe, bar magnets should be kept in pairs with their unlike poles on the same side. They must be separated by a piece of wood, and 2 pieces of soft iron should be placed across their ends. For a horseshoe magnet, a single piece of soft iron can be used as a magnetic keeper across the poles. Usage of magnets. We use various equipment with magnets in day-to-day life. We use magnets in speakers, in small electric motors, in some door locks, and in bags, in some toys, in compasses, in pencil boxes, and stickers on refrigerators, phone covers, pin holders, and in magnetic crane. We know that like poles of the magnet repel each other. By using repulsion, we can levitate a magnetic object. Let us make a toy and enjoy magnetic levitation. So we are going to make a levitating propeller. To make the levitating propeller, we need ring magnets, bottle propeller, plastic bottle filled with sand, tape, stiff plastic straw, and scissors. First step, make a propeller from a 500 ml plastic bottle. Make a hole in the bottle lid as shown in the picture. Next, screw the lid with the hole on a bottle off filled with sand. Fit a stiff straw in the lid. Embed the straw in the sand to make it stand erect. Third step, place two magnets each inside and outside the propeller lid. These magnets will automatically stick to each other. The fourth step, place a few ring magnets in the straw so similar poles will repel each other. Finally, place the propeller on the stiff straw. The magnets in the straw and the propeller should repel each other. This will make the propeller levitate. On placing it under a ceiling fan, the propeller will spin very fast. So, light poles repel and this levitates the bottle fan. The ceiling fan makes it spin. Now, our levitating propeller is ready. Electromagnetic train is working in the same principle. Have you heard about it? Electromagnetic train is called as suspension train and also called as flying train. It does not require diesel or petrol. This technology uses the property of magnetic attraction and repulsion to run these superfast electromagnetic trains. Come, let's learn about that. Maglev train or electromagnetic train. Maglev is nothing but its magnetic levitation. Electromagnets are used in electromagnetic train. Electromagnets are magnetized only when current flows through them. When the direction of current is changed, the poles of the electromagnets are also changed. Like poles of the magnet which are attached at the bottom of the train and rail track repel each other. So the train is lifted from the track up to a height of 10 centimeter. How does the electromagnetic train work? We know that we can move any magnetic object with the force of attraction or repulsion properties of magnets. This train also moves with the help of the magnets attached on the sides of track and the magnets fitted at the bottom side way of the train. By controlling the current, we can control the magnets and movement of the train. As there are no moving parts, there is no friction. So the train can easily attain a speed of 300 km per hour. These trains are capable of running up to 600 km per hour. They do not make any noise, they require less energy, and they are eco-friendly. Even though many countries have taken effort to use these trains, such trains are used for public transport only in China, Japan, and South Korea. In India, the possibilities of introducing these trains are under consideration.